think now we're ready and
Right.
we can start today's meeting.
So welcome to this first series of webinars. We are planning to launch once per month. My name is Michał. I'm the Business Development Manager in the Nordics. And the intention of this webinar series is really to inspire you on your data-driven journey in the area of data AI and GenAI. And the first, as you can see, the first theme is not surprisingly GenAI. And the focus will be mostly on use cases, examples, and values that we've seen in this area. The second webinar will be launched first week of December and will focus more on data strategy services in the world of multiple AI innovations. So you can expect a series of events over the coming, hopefully the coming year. So and with that, I'd like to hand over to the main attraction, the two speakers of today. So that's Michał and Piotr, and hopefully you can say a few words about yourself before we kick off. Perhaps I should also emphasize that we encourage you to ask questions in the chat, and we will pick up the questions at the end of the event. But and hopefully, perhaps I should also mention just before a little bit of sales talk just before we start, but not much. So Getting Data is a consultancy firm with specialist consultants in data and AI and GenAI. We're also part of a bigger group called Cebia, and Cebia has close to 6,000 people, and we do other things as well, like transformational services, cloud, and data strategy services. But again, most welcome, and as mentioned, hopefully there will be one event per month. And again, we will publish the next event immediately after this one, and we're shooting for the first week of December. So with that, I'd like to hand over to Michał and Piotr, and perhaps again you can say a few words about yourself, and then we kick off.
Thanks, Jimmy, for the introduction. So let me start. Hi, my name is Michał Bryś. I'm machine learning architect at Getting Data. I help to build machine learning solutions for our customers and also onboard the new users to that produce solutions. So I will be the speaker for today, together with Piotr. So Piotr, can you introduce?
Yeah. Hi, everyone. I'm Piotr Chaberski, and I'm a senior data scientist here at Getting Data. And over the last few months, I was mostly involved in GenAI initiatives, so I hope I will be able to share something interesting with you on that topic. Okay, so let's start with it. So here's the agenda for today. We'll start with the basics to explain what GenAI and especially large language models are. What are the new possibilities that they bring compared to classic machine learning approaches. I will briefly present you the current landscape of large language models that are available to use. Then Michał will present some challenges and issues that you may encounter when implementing those solutions. And finally, we will share some practical use cases, focusing on one particular use case, but we will get to that. Okay, so let's start. Can we go to the next slide? Yeah, so what generative AI and LLMs are? Yeah, so if you are here on this webinar, you must have heard about generative AI. And this is something that is discussed, especially this year, by everyone in the business, even people that didn't have much in common with AI now heard about AI and especially generative AI. But this is something that it's not really something new. Generative AI or generative modeling have been around for decades. It just took a new form, let's say, because statistical models that are able to generate some new data or some more classic right now techniques like generative adversarial networks or autoencoders. This is something that is still in use in many applications. But now something that really made a difference were especially transformer-based models, which are, for example, large language models. And also, if we talk about some visual data, very important player on the field are diffusion models. With all these models, we are able to generate not only text data or tabular data, but also code, speech, synthetic music, images, or even video. But in general, simplifying a lot, all those techniques work in a way that we have some model that is able to that we can train on some input data, and it is able to capture characteristics of this data in some encoded form, and from these encodings, it is able to generate new data. Okay, let's go further. And large language models are a subset of generative AI that is focused on mostly on text data. So LLMs are trained on a very, very large corpora of text data that is often multilingual, that comes from different domains. And in their parameters, they capture the characteristics of this data, and they are able to generate new text data. But basically, there are some nuances. But let's say that the actual task of LLM is just predicting the next token or next word in a sequence of words. So if we provide a sequence of words to the model, it is able to predict what is the most probable next word. And all the amazing use cases that we will show and that you might have heard of are just based on that simple thing, that we are just predicting the next word in a sequence. Okay, well, let's go to the next slide. Yeah, new possibilities brought by LLMs. I would like to briefly tell you about two things. So the first thing, let's go to the next slide, is that generative AI, or especially LLMs, introduce the new way of using the models, or the classic way of using machine learning models was like we have some very specific task, and we need to find the best algorithm for that task. Using this algorithm, we need to train the model, and then we can execute this specific task in a very framed way. So, for example, if we have some labeled tabular data with some characteristics of houses and some historical prices of those houses, we can apply some algorithm like linear regression or some tree-based model and perform estimation of this house price, but of prices for some new houses that appear on the market, for example. But this is, as you can hear, it is very narrow. We have just specific data set, we have selected algorithm, and we have very specific task. You can see also other examples on the slide, but let's go further. LLMs are very different in that matter because, as I mentioned before, they are trained on a very large text data sets and encode all the knowledge that is available in those data sets. And then these are called foundation models. So they just encode all the knowledge from large text corpora. And we are able just to providing a specific instruction for this foundation model, we are able to perform very different tasks. So the same model, even without any modifications, any fine-tuning that we'll be talking about, just the foundation model, if we instruct it properly in natural language also, it will be able, for example, to perform sentiment classification, to summarize text, and do many different tasks. Okay, let's go to the next slide. Yeah, and the other difference that I would like to highlight is that in a classic way to interact with ML models, you usually needed to do a lot of coding. Of course, there were some visual interfaces for some models and so on, but really to get deep and to get models to really do what you want for specific tasks, you needed to do a lot of code development. For LLMs, at least for the simpler applications, you just need to provide a specific instruction called prompt that will tell the model in natural language what you want, and it's very high chance that the model will understand what you mean and will perform this task correctly. Okay, let's go. Yeah, but of course, it's not like usually it's not like that you just provide one sentence instruction and the model will guess everything that you want. There are more sophisticated use cases that we also talk about in a minute. And those use cases will require some more advanced techniques, but they are all based on careful prompt design. So, for example, we can provide to the model, in addition to the instruction, like, for example, I need you to classify some sentences if they are positive or negative. We can help the model by providing some examples, and this is called few-shot prompting. And also for even more advanced tasks, there are techniques like chain of thought or reason and act techniques that when we provide more explanation, more context, and more reasoning examples for the model. Okay. And just very briefly about the current landscape of large language models. We have basic division can be that we have a commercial offerings and open source models. Let's see the next slide. And every major cloud provider have some offering. Azure teamed up with OpenAI offering GPT models. via the infrastructure. Google Cloud is developing their own model called Palm. AWS took a different strategy because they teamed up with multiple providers, and they are also trying to develop lately their own model called Amazon Titan. But on the other hand, we have also open source offering that are fully flexible, and we have a full control over what's happening in the model and how it's used, but we need to deploy those models on our own. And this is the right-hand side of the slide with some examples. Okay, so now I will give the voice to Michał, who will discuss some challenges when applying LLMs in real applications.
Yes, thanks, Piotr, for the introduction to the generative AI topic. And now let's talk about the challenges and the questions which arise when we come to the details. We want to build something, some solution, and to introduce that solution to the end users, maybe to our business use case, and to implement generative AI and build in to our product. So let's walk through quickly about the challenges of the large language model based solutions. Because when it comes to the details, many questions arise. First group of the questions is the privacy and compliance aspects of the generative AI in general. So here is like the quick checklist, what you want to need to be sure, and what you want to double check before you go with the generative AI to the business and to the real life use cases. So first question is, does my data need to leave my infrastructure? Because quite often companies have some proprietary data. You've got some personal information. You don't want to share this with some external software vendors. There are sensitive data. So sometimes you don't want to share that outside of your organization and outside of your company. So you need to double check if the use case you want to implement requires sending data out of your company and out of your infrastructure. Another question, another item on the checklist is that, will my data be used for the future model training? You want to double check, and you have to be sure that your proprietary data will not leak your secrets and the business and the internal knowledge to the general database, which will be used for the future model training. Sometimes it happens, sometimes it's enabled by default. So just double check if you are not sharing your business secrets outside, because you can imagine, like in the future versions of the model, the output for your competitors may include your business secrets. It was some examples at the early stages of generative AI and large language models of the companies that leaked their business secrets to the general database used for training the foundation models. So just always double check how about the future data usage. Another thing to double check is how about the license of the model, because sometimes the license for the model you want to use is proprietary. Sometimes it's open source. There are different kinds of licenses. Sometimes the model architecture is open, but the actual model weights it's not open. So you have to double check always with your law department if you can use the exact model, because it's more complex than it seems for the first view. Another aspect, especially for the regulated industries like finance, insurance companies, or healthcare, is how about the responsibility for the generated content? Because if you leave your model without the attendance, it can produce some content which can be next used to make some business decisions. So how about the responsibility for the wrong decisions, let's say, based on the generated content for the generative AI? So just to summarize this, check always that steps and read carefully the terms of use and licenses of the model. you want to implement. Another thing beyond the data privacy is the aspect that generative AI is still new, and the tools we've got available is still not major. It is changing constantly. Tools and models are improving every day almost. We've got some new improvements, but let's see how immature it could be. So here there is an example of the financial data summarization. So the scenario is that we've got example financial report about the company revenue across multiple years, and we asked large language foundation model to generate the executive summary of that data and to generate some basic insights, to summarize this and to share that insights with the stakeholders. So let's see what the model produced. So we've got the output from the example model. So at the first glance, it looks like really verbose and really extensive thing. But when we look to the details, you can see like the technology is still not perfect, and that model produced something out of the scope. So the model summarizes the data from the next 10 years out of the data we provided. It make up some units about the data. We've got even some insights about 2017, even if we've got the date range until 2010. So we've got the data about 2017, which is not in the initial data set. We've got even some interpretation like why revenue changed 10 years later. So you can see like the technology seems really promising, but you should always check the results, because models and technologies we've got available are still new, and they are also immature, and it may lead to some real business use cases without attendance of that model. So immature tool is another challenge of that generative AI use cases. Another thing, why it's still fresh. So we just found some insight talking about how dynamic growth of LLM was. Here on the chart you can see the timeline and the time to get for the company 100 million global monthly users. So for companies like and products like Google Translate or Uber or Telegram, it took tens of months to get 1 million users. For the ChatGPT, it was 2 months. So you can observe like how dynamic and how fast grow it was. So we've got really fresh technologies that gained a really great adoption on the market, but still it's really early stage. Also, companies are trying to structure that process and maybe to build some good practices around productization of machine learning models focused on large language models. And here is the Google Trends chart to illustrate the popularity of the search terms in the search engine about the MLOps compared to the LLM ops. So MLOps is about implementing machine learning models in general in production, and we can see like it is growing since 2020, and we've got also observed that LLM ops is also growing topic. So, but you can see the difference in the popularity. So here with productionizing large language models, we are somewhere where MLOps was 3-4 years ago. So that topic is gaining attention, but it's still fresh and it is on the beginning of the journey. And it's hard to compare the maturity of the LLM ops solutions to the MLOps things. So many companies are doing their own approach to productization of the large language models. We do this also. So this is our approach to make the system around the generative AI and how to make that models work in the organization. So we propose also some framework called GenAI platform, which consists of parts and modules to manage models, because sometimes you've got the model on your side, sometimes you are using the third-party API, and so on. Another building block is the component to manage prompts to large language models. Another building block is the monitoring and observability of the generative AI models inputs and outputs. And also we want to expose that model internally, for example, to your organization across some interface for the end user or API to interact this with the programming language. And of course, as a baseline, you need some infrastructure, for example, for the cloud and the data foundation. So this is our approach, how we would like to prepare the generative AI to adopt this within your project in the company. Another challenge for the generative AI and large language models specifically is the cost, because there are no free lunches generally, but especially in the AI. So if you think about the economic impact and how much does it cost, so usually we've got two options. First, we can get large language models pre-trained from someone else by other company, or we can use third-party API to call that pre-trained large language models. But it is still not for free, because there is an inference cost, because you are paying for the tokens processed by generative AI, like input and output. If you would like to do the fine-tuning of the model, it's not also for free. If you have your own, even open source LLM model, you need to host this something. So you are paying for the infrastructure to host that model. Like the name, large language models are not small. So you've got some, probably you will need to get some powerful compute and storage infrastructure to pay. And also you need to include some licensing costs in the model usage. So even if you take the free and open source large language models, you need to reserve some budget to handle that model and implement this in your projects. Another thing is that if you decide to train your own large language model from scratch, so also it will be much more expensive, because you will need to hire experts with the expert knowledge. You will need to gain your own training data set. It's okay if you have your own internal database of the documents to train the model, but probably you will need some large data sets, so you need to pay the license or gather that data and make sure that you can use it for the model training. Large language models also require some extensive data preprocessing. So if you've got a big input data set, you need to do extensive data processing and model training. It means also extensive cost of the infrastructure. So we can summarize this like large models require large wallets. And another thing about another angle of the large language models challenges is the problems of the early stage of the technology, which is hallucinations, bias, and unpredictability. So it is changing and it is constantly improving, but here you've got example, like sometimes large language models will give you the answer and it will be sound really really confident about your question, even if that question makes no sense. Here there is an example like, what are 5 popular scientific papers that prove the world is flat? We know that world is not flat, but that large language model will produce some scientific papers for you with the title, author, confirming your answer. So you have to be really careful, like what you are asking for. We know also some examples from the healthcare industries, like where the healthcare researchers did some testing on large language models and asking about some specific things, and it returned also the list of publications, but it was no that publication is like there. So it sounds really confident, but actually it was really big hallucination of the model. So you should be really careful about the model and output. As I mentioned, like it is constantly improving. So the first example was from the early stages. Now here the example from GPT model. This model will say that there is no scientific evidence about the Earth is flat. So we can see like that model are improving, and even if your question is sounds right, it will the model will say you are wrong. Another group of open challenges is the licensing, because like we mentioned and Piotr discussed, there are different large language models available on the market. We've got commercial services, which we don't know the model itself, it's like black box, but so the license for the model is proprietary. We can use it and pay, but we don't have access to the model and the model architecture and data set and so on. There are also some open source models, but allowed only for non-commercial usage. Another group of models are licensed on the Apache 2 license. There is also different and dedicated license type Llama 2 community for the different models, and there are MIT license models and so on. So you should double check always the model license and the dataset license, which was used to model train, because it could be different license for the model itself, like model architecture. Another license could be for the model weights, so the actual trained model, and another license could be for the dataset the model was trained on. So you should be really careful with this, just to make proper things and not make some business mistake on this. And of course, this list is not complete, because we've got more open challenges in large language models, like the time of training, the time of inference, sometimes how to handle large volume of the queries to the large language models, how to use large language models for non-English languages, and so on. So I also recommend that blog to read about the still open challenges in large language models. Yes, so now it's time to walk through the practical use cases, and Piotr will do this.
Yeah, so let's start with the first use case. I will briefly show a few use cases, and then Michał will present you in detail one of them. But let's start with some overview. Okay, so let's imagine that you have some collection of text documents that are really valuable and contain much interesting information that could be used for analytics, for visualization, and for machine learning, but they are just plain text and they are not usable in this form. And in this case, LLMs can come to help in a pretty simple way, and they are pretty robust with transforming such unstructured text to a structured form, for example, like here to JSON, or to directly to a table. And in this structured form, you obviously can use it for different purposes. Okay, let's go to the next use case. Another popular application of LLMs is knowledge retrieval, and all companies have some internal data, and it can be unstructured, like in the form of PDFs, web pages, like wikis, Confluence pages, text documents, and so on. Or it can be already structured in the form of some database or data warehouse. In both cases, we can use LLM as a kind of connector to this data. Because on the other hand, we can tell LLM to generate, for example, SQL queries with the information that we want to extract, and this query will be executed on the SQL database. And also, if we have unstructured documents, we can index them and insert them into some vector database, and perform vector search to extract needed information. And on top of that, we can build, for example, some chat interface when we just provide instructions in natural language, and the LLM will either generate SQL queries or search for the information in unstructured documents. Okay, going further, if we think not only about knowledge extraction or question answering, but if we want to build some more comprehensive AI assistant, and there are also many possibilities to do that, because we can plug in not only some internal knowledge base as before, but we can also design the AI agent that uses LLM multiple times in the process to use other tools, like, for example, web search, some calculator, or that is able to access some other machine learning models, like recommendation systems or some forecasters or other predictive models. And we can also build some chat interface to that has also some memory module. And in this way, we can create some experience for the user that the user is talking to a real assistant that is able to do a lot of different tasks for him. So, okay, let's go to the next slide. This is pretty basic usage that probably you are familiar with already. So with just a simple prompt, you can use LLM to generate some content. For example, we could have, I'm not saying that we did, but we could have generated a LinkedIn post advertising this webinar just by letting some LLM like ChatGPT here to do that for us. But there are also more content generation use cases that are valuable for the business, like, for example, code generation in different programming languages that is facilitating developers' work, or even generating synthetic data for other machine learning models or for different analytical purposes. Okay, let's go. Okay, this is a particular very specific use case. You can imagine that in your company you have some documents that are very domain specific, like legal acts, like scientific papers, like medical documents or financial reports. And obviously in your company you have domain experts that understand all of it, but maybe other people in different roles also need to access and understand them. So using LLMs, you can build something that you can call a reading assistant. And for example, when somebody reads a document that is domain specific and contains some difficult terms, in a standard way, he would need to, do a lot of Googling or asking or searching for other papers to explain what's written, and it would take a lot of time to decode the domain-specific document. But using LLMs, especially LLMs that are capable of using some external sources of data, we can do it in a much easier way, because we can just point some portion of text and summarize it, or point some term and ask LLM to explain it, or search for references in the documents that we are reading on, or in other documents. Okay, next slide. Yeah, and as the name states, we are talking still about language models, and those language models are trained on text that usually are in different languages. So LLMs, of course, they are language-specific models also, but many LLMs are multilingual, because they are trained on text in different languages. So they have a natural capability of translating texts. But let's imagine that, again, you have some very domain-specific document, like, for example, from a medical domain, that, you can see that the example on the slide. I cannot understand even the title of that document. So let's imagine that you need to translate it to some other language. Of course, Google Translate or some other popular service won't help, because one thing is that it isn't trained on a domain-specific training set. So it's also, just like you, doesn't know those difficult terms and cannot translate them. And the other thing is that you probably cannot use even some open services, because those documents might be proprietary. But using some LLM and plugging in some domain-specific knowledge base containing nomenclature and some other documents that help LLM to translate those domain-specific terms to other languages, you can do that actually. Okay, and this is just to show that we are not talking purely theoretically about those use cases. Here are some examples of the use cases that we already implemented, either as a project for our customers, or as some POCs in our R&D units. So, for example, we have some implementations for advertisement parsing. We have some solution that is able to perform search in medical documentation and form endpoint references. We have this reading assistant that I mentioned, that is helping to understand some domain-specific documents. We have the implementation of a knowledge retrieval system from unstructured documents, and this is the use case that Michał will elaborate on in just a second. We also implemented conversational interface to the SQL database that I also mentioned, and we have some attempts to implement also this comprehensive AI assistant on the example of e-commerce dataset. Okay, so that's it from me for now.
Thanks. So for the dessert, let's do the really deep dive of the one problem about how to attack and how to solve the problem of machine learning models, large language models, hallucinations. So let's talk about grounding large language models with the retrieval augmented generation architecture. So just to overview the problems of the foundation large language models and the challenges. So using the out-of-the-box pre-trained model means also sometimes that model can have outdated knowledge. You can remember the early stages, the early versions of the large language models. They are trained on the data until the 2021. It means like they don't know what happened in the last 2 years. They have general knowledge about the language, so they are missing domain-specific terminology. Sometimes it's problem with the transparency and interpretability. We've got model hallucinations, but hopefully there is the technique called grounding. Another thing is the cybersecurity threats about the model, because there are attempts to prompt injections, supply chain poisoning, and so on. So large foundation models are also prone to that kind of cybersecurity risks, and also the cost and complexity of training the large language model from scratch is there is some trade-off between that cost and complexity and the performance of the that model in terms of the responses generated and the performance of the model, like technically. So we agreed that training the large language model from scratch is too expensive and too complex. So how to make use of the large language models in the general form, but also how to improve the results quality and to make the model hallucinate less. So there are different techniques how to do this. First is the full fine-tuning of the model. Another option is the parameter efficient fine-tuning, do the extensive prompt engineering, and the retrieval augmented generation, which we will do some deep dive on. So we can do a full fine-tuning of the model. So we can take the foundation model, implement some domain-specific data set, and learn and fine-tune the model to use that domain-specific knowledge. So it will increase the accuracy and the robustness of the model, but also it's expensive and complex in terms of hardware, infrastructure, and the expert knowledge required to do this. Another approach is the parameter-efficient fine-tuning. It uses some optimized process to fine-tune that model. So uses fewer resources for tuning and multiple task specific, and you can create multiple task specific models, but also it's still complex, and there are a lot of methods to implement. It means like it requires also some expert knowledge. Another approach to improve the large language model results and include the domain knowledge is do some prompt engineering. So maybe you can include some context in your prompt, some examples, and do the task question strategy of interacting with large language models, but it still has some limitations. For example, you cannot put your all documents available in the dataset in the company as a context, because, for example, the context has like limited size. So the last approach how to improve and how the large language model results and how to ground that model and make it hallucinate less is the retrieval augmented generation. It means like we we've got some domain-specific data set, we've got some vector database, and during the conversation with large language models, we use the data gathered in that vector database, and we use only the large language models to process the results from that document vector database, but not figuring out the answer from the general knowledge. So how it looks like. So here there is an example of the conversation with our model and about the technology specific to the implementation of machine learning models. So we ask the model how to integrate MLflow with Snowflake. So this is the example of the question about two particular technologies. So under the hood, it makes a query after we ask the question, it makes a query to the our data sets of documents. Here it's the database of the blog posts and in the PDF format, so it's unstructured text, and that model using also LangChain will list the references, so it will list the documents related to our query, along with the matching score and the document name and the reference to the actual document. It will list the content of the document which is related to our question, and it will return a list of that references with the content, and the large language models will be used only to aggregate and to summarize that content of the documents in our company. So we will get the response based on the documents in the database. What's more, if we will ask the question out of the domain knowledge and out of the scope of our documents, like here, what is NFC, near field communication, which was not described in our knowledge domain dataset, we can build our system in the way that it will not make up the answer. So if we will ask about something which is not included in the database, the model will not hallucinate and generate some make-up answer, but it can answer, I cannot determine the answer to task because it's not in the document. So this is also a good way how to ground that model and limit the creativity of that model in generating wrong answers. Just to compare,
Michał, I just want to say that we have 5 minutes left, so we need to leave some time for Q&A as well.
Yes. And the last thing is how the question, if we ask the general model without that domain specific knowledge, we will get another answer like really low level and specific without the review of different technologies. So there is the comparison how it looks like when we ask the general model about that question. And yes, it was the last thing we would like to discuss. If you would like to read more about the use cases, we described some of them on our Getting Data blog, including that reading assistant Piotr discussed. For those who are more interested in some technical details and some deeper dive on the technical implementation, you can watch the webinar. I think Claudia will post the link in the chat to that resource. And yes, also we've got some time to pick up questions, but during that time also remember to leave your feedback also using the link on chat. So yes, we are waiting for your feedback and also we are waiting for your questions. So let me check that questions on chat.
I don't think we have any questions at this point.
Okay, so
you have been crystal clear, perhaps. Well, and in the meantime, I just want to mention again then that we will have this series of webinars on the theme of data AI and GenAI, and the next one again is coming up first week of December, and it will be posted soon somewhere near you, so you can enroll to it. So just look out for it. It will come in the coming week or so, and hopefully you have a chance to join that as well. But I can't see any.
I see some issue with the chat, with the question chat. But maybe if somebody has a question, can just put it into the chat, not in the question field.
Now we have some comments here.
Yeah, we've got 2 questions.
Yeah, we have a few here. Can you see that, Michał or Piotr?
I can pick the first question, and the question is how much it costs to run a retrieval augmented generation if in 50 people organization. Is it cheap or requires investment? So I can share one example we implemented actually on GCP, on Google Cloud Platform, using previously it was matching engine, now it's vector search. So we can implement that thing there. So it was the cost for the infrastructure. There is a few things. First thing is that vector database. So it depends on the size of our documents database. We put there tens of PDFs, so it was not 2 big data sets. And for that instance, it was around $15 per day of running that instance. So this is like the constant thing, constant cost of keeping that vector database on. And the second thing depends on the usage, because we in that use case we used large language models, the Palm model available also on GCP. So that model is priced by the tokens processed. So also it means like it depends on the usage level. The more people, the more answers and questions will generate more tokens to charge. So just to give you some brief example of this, we've got the static cost of the infrastructure for running a vector database, which was around $15 per day in our case, and then it depends on the usage of the database. So you can think, is it expensive or not? It depends on your budget. I think it's like reasonable cost to handle. Okay.
Quite a few people are logging out now, so I just want to take the opportunity before everyone leaves to thanks for joining this webinar. And again, look out for the next on data strategy, which will come in the coming week. But we still have, I believe, a question here.
Yes, that last question is about the licensing, a challenge of the LLMs, but I think you can check it in the recording later.
All right, so then we have covered the questions. So again, thanks very much for joining, and we will be back, no doubt, first week of December, and hopefully you can join again. Thank you very much, everyone.
Thank you.
Thank you. Have a good one.
Thank you.